just go down the line to have them introduce themselves quickly.
I am David, and this is Rover. What this Rover has right now is it has a bunch of sonars in the front. It has a webcam, wheels, motors, a computer right here, this little black box. And what it's running right now is my ant. This Rover thinks it's an ant right now, so it's going to behave like one. It's going to go randomly, and if it sees something on the ground, it'll mark it and then head back to home. The sonar sees what's in front of it, and it avoids that obstacle. It'll go around it instead. And this is Sammy.
Hi, I'm Sammy. I'm the teammate of this group too. We're working on this rover to program this brain to let it to know what to do in the Mars and operate with other rovers, because they are not just one on the Mars. They have their 3 more or 6 more.
Yeah, so hi everyone, my name is Joe. I am a computer science student here at PCC, but I wasn't always a computer science student. I actually did my undergraduate degree in philosophy.
So this workshop is going to be a lot of interactivity with you guys, so we're going to have you be walking around a lot. Well, not that much, but you're not going to be sitting the whole entire time. So the next thing that we're going to do is we're going to show you how the rover will move around, and it has a sensor detection on it, so that allows it to know when it's going to crash into something or not. So we're actually going to have all of you guys stand up and then make a line this way. Make a line this way. And then this other side, this wall is going to act as the other side of the maze. So yeah, not too close to that. That's good. So now the rover is supposed to reach the end, but he does not want to crash into anything.
Oh no!
So the next thing that we're going to do is we're going to have it just go kind of crazy. So as you saw, it was slowly turning with the wheels. He's going to be programming it right now. So as you said, remember he said there was a computer in the robot. So he's going to go into the code. You can actually see all the code on the computer, on the TV. And he's going to go into a specific area of the code that changes the wheels. So he's going to make one, bless you. He's going to make one set of the wheels spin at a certain velocity or a speed, and the other set of the wheels spin at another velocity. So that means it's going to be spinning in a circle. And you'll see that as he's setting it up right now.
Would you mind to ask you guys some questions? What grade are you from? 6th, okay. And 7th and 5th, okay, excellent. So in that age range, are you all from the same school or different schools?
Different schools.
Oh, cool. Where are you guys coming from? Sierra Madre, okay.
Elementary school.
Love it. That's fantastic. So is this the first technology event that you've been to?
Mm-hmm.
Some of you have, some of you haven't. Okay, so what have you been to before? What'd you like?
At school, we go to robotics.
Okay, tell me about that. What do you do?
We're actually making a robot, and on Thursday we're gonna have a competition.
Excellent. What's the robot do?
It's supposed to carry and walk. It's supposed to carry a cube. And it's supposed to drop it.
Okay.
Yeah.
Excellent. Great. And some hands over here. Yeah.
Attention.
I
learned. She went also.
Yeah. And so what was that about?
It was the whole week, and we got through a lot of different projects with the different teachers over there.
Okay, so some of you have experience with robots before, so you know that when you tell a robot to do something, it doesn't always do what you want, right? And that's been one of the biggest challenges that we've had, because we're trying to get these rovers to work together as teams, right? So we have you ever seen ants swarming toward a piece of food that's on the ground? They're all in a line, and they don't hit each other, they just sort of walk over each other, and they're in 2 little organized bits. They go toward it, they get some food, and then they go back home with the food. Well, that's kind of what we want the robots to be able to do too. And so one of the things that we've been working on is figuring out where the nest is, where home is, and figuring out how we can return back to the nest, back to home. Have you ever used a map on your phone to get somewhere? So that uses a technology called GPS, or Global Positioning System, right? And that's accurate enough for when you're driving around in a car. right? It'll tell you what freeway you're on, like what street you're on maybe, and it'll, maybe the computer will know where Target is or where your house is, and you can sort of get there using your phone. The computers, the robots, don't have really good maps built up. So there's no like Google Maps for these robots, right? Especially if they're exploring new areas on Mars. If humans have never been there, we haven't mapped it yet. And so how does it get back home? There's no GPS, as it were, on Mars. And so we've been trying to figure out, okay, can we figure out based on how many times the wheels have turned, how far the robot has gone? I think that we're ready to go ahead and show you some code now.
Okay, so what is you doing, David?
Okay, so what I'm doing is accessing the file inside the rover right now. And this is the actual code right here.
Can you make it bigger?
Yeah. So this is everything in the mobility file right now. There's many files. There's files everywhere in the rovers. This is the mobility file. It's going to change how the robot moves. So what I'm going to do right now is I am going to have the robot spin in place a whole bunch of times.
How many of you know about this code? You know how to write the code? No? It's not that hard. Look at it. See what it says.
What's happening? Okay.
Okay, so the next activity that we're going to do is we are going to pretend that we are the robot, and we're going to be searching for things on Mars, but these things are going to be candy. So we have a lot of candy, but we're going to have to designate half of you to be the rover that's doing the searching, and half of you guys are going to be the sensor detector. So how this is going to work is then I'm going to be the robot, but the robot can't see. He has a very limited vision. So what I'm going to do to replicate that is I'm going to put a bucket over my head. And the only thing that I'm able to see are my feet. And then, so I'm not going to know where I'm going. I might be crashing into things. And then that's why I'm going to have my sensor detector. You want to be my sensor detector? Yes, you do. Okay. So your job is you're going to just tap on my shoulder and tell me when to stop if I'm going to crash into something. Because I'm $100,000 equipment and I don't want to be exploded and then lose all the data the scientists work very hard on. Okay? So I'm just going to be walking around and pretend this is candy right now. Okay, I need to pick that up, but I don't know where it is. So I'm going to think of the best way to search an area. Oh, look, candy. Okay, so I'm going to be walking around and I can't see much, but the sensor detector. Okay, so I'm going to be walking around and then, so I see something here. So I'm going to pick it up, and then I'm going to hold it, and I'll walk some more. I'm going somewhere here. Where is it? So see, I don't know where. Okay, hold on. It's kind of similar how you see the robot, and when it was like walking one way, and then it was like shifting a little and went to a different direction. So that's exactly what you guys are going to do. So we want you guys to create what we call an algorithm. Do any of you guys know what an algorithm is? Have you heard of the word? Okay, so an algorithm is a step-by-step instruction, an instruction guide. So it's kind of like a cookbook. First step, you do this.
Say that again, please.
Sorry?
Say that again.
Oh, okay.
What
So
is an algorithm?
An algorithm is what computer scientists use to describe a step-by-step process. So it's similar to a cookbook when you have step 1, you take out the eggs, step 2, like turn your oven to 300 degrees. They have a certain step-by-step process that you have to follow. And if you don't follow it in that order, then something will go wrong. That's why you have to go back and fix the code or to think about a new algorithm that might work better. So what we want you guys to do for just like 5 minutes is to think of a way to search this entire room. And there's going to be candy everywhere. So you're going to think of the best way to collect as many pieces of candy as a team. Because the robots, they aren't competing against each other. They want to collect as much data as they can to give back to the scientists. That's why we have multiple robots. So we want all the robots to work together to get the candy, or whatever stuff is on Mars. So right now you can just kind of think of ways. Do you want to walk diagonally, or do you want to walk in zigzags, or do you want to work in circles? Think of the best way, or you can just completely randomly walk. So each of you, because each of you will get a turn, we'll switch off between the rover and the sensor detector. So just think of a way that you might want to explore an area if you can't see it. You help her get him to like kind of walk over here. And then you can maybe do a little bit back here. Walk over back here. And you're good here, and you can walk back forward. And on the floor? Yeah, because that's where the stuff are. Yeah. Okay, so you can't be, don't be big. Don't break them. Like, gently.
It's chocolate.
Okay. So then you also don't want them to run over your specimen. Like if this was a live plant on Mars, you don't want them to run over and kill the only data that you're trying to look for. So you have to watch out for that. And then also see, if you're going to crash into each other, you don't want that to happen either.
Are we going out here?
You have some space. Okay. All right. Okay. Don't step on them. Don't kill the live data. All right. Okay. So you're gonna let the should we time them? We'll say 5 minutes to collect as much candy as a team, okay? Ready? And remember the rules. You cannot say it's over here to your left or to your right. The only thing you can say is stop and pat them on the shoulder, because if everyone's out saying stop, then you might get confused. Okay, so ready? We have a timer. Okay, ready, set, go. You can pick it up if you want, yeah, you can pick it up. We don't want to crash the things. Remember, we're very expensive equipment. Oh, after crashing, $100,000 equipment is breaking. Oh, that rover just exploded. Oh, there's still some there. Seems like you.
Pieces over here.
There are aliens helping you on Mars. Alright, so you guys got most of it. Now we're going to switch off. So if you are a rover, you're going to be a sensor detector.
Oh, that's it. They got it. The last piece.
Okay, so let's all switch. And then once you put the bucket on your head, if you were a sensor detector, oh, you can put your candy somewhere. So
Alright, so did you like this event? Like from a scale of 1 to 10, from 1 being the worst and 10 being the best experience, what would you say?
9.
A 9? How about you?
10.
10. 9. 10.
10.
10.
10.
10. Wow, so you guys really like the event.
thank you.
What did you learn from the event?
There's a lot of different types of programming for robots.
Good.
You?
That if the code isn't corrected, the robot won't do what you want.
Oh, good.
Very good. And do you know what we call to correct that mistake? Yes. Can you say that louder?
Debugging.
Yes. Very good. Very good. All right. Yes. You.
I figured out today that it takes time for robots to learn the place where the area they are, and so
Yeah. So it doesn't happen right away. They don't go to a new place and know right away. Yep. They have to explore first. Very good. Anyone else? Yes.
It's sensors are a very important part of the robot, so it doesn't crash itself.
And what happens if it crashes?
Then it gets broken and it doesn't work properly.
And these are very cheap equipment or very expensive equipment?
Expensive.
Yeah. Okay, very good. Anyone else want to share anything?
Yeah. Anyone want to share?
If it crashes, $25,000 goes to trash.
Yes.
Yes.
Okay.
So how many of you would be interested in coding when you get to college? Ooh, we have people interested. That's good.
And how many of you want to go to NASA when you graduate? To work over there. It's a cool place to work.
How many of you want to go to Mars?
You won't have buckets on your heads in Mars. All right. Well, thank you so much for your time.
Thank you.